Okay, you guys have a little review from lessons 4.4 to 4.7. So this is like our second half of chapter 4 review, and I've assigned you guys the evens, but I've selected a few of the odds that didn't have examples in the textbook. So or in at least the review section of the textbook. So my first one is number 37, and this is from lesson 4.4. It says, describe how the graph of f of x and g of x are related. And so basically that's just asking what's the transformation there. Then find the amplitude and period of g of x, and sketch at least one period of both functions on the same coordinate axis. So let's start out with how they're related. So the relationship, we have a change in the amplitude, which that's going to give me a vertical stretch by 5, and it's going to be up and down. So really it's a total of 10 if you want to get really technical there. But that's the first thing we're going to do. And then the second thing is to figure out what the amplitude and period is of g of x. So we're looking at just this function. The amplitude is the multiplier on sine, and so it's 5 there. And the period, because it's 1b, there's no change in the period, so the period is going to be 2 pi. And the third thing is to sketch at least one period of both functions on the same axes. So I'm just going to kind of give a rough drawing here. We have our origin, my x-axis, and our period is from 0 to 2 pi, so we'll make this 2 pi. Here's pi over 2, and 3 pi over 2. And I'm going to make this 1, and so this is 5 here. Actually, I'm going to have to make that a little bit longer. Kind of going to scoot into my instructions just a little bit, but I think we'll be okay. So here's 1, and here's 5 down here. So when I graph f of x, that's just a normal sine function. We're going to begin at 0 and end at 2 pi, and then we'll also have a 0 at pi, and then we have a maximum of 1 and a minimum at -1. And so here is, we don't want to forget our arrows, but this is f of x. And then g of x is just a change in the amplitude. So our zeros are going to be the same, but we're multiplying by 5, so we'll have an amplitude, we'll have a maximum of 5 and a minimum of -5. And so this is g of x, and you would want to label those as well. And that's all for that particular problem. And you had a couple like that to do in your assignment. Number 47, this is from lesson 4.5, and it says locate the vertical asymptotes and sketch the graph of each function. So in the example that they give you, I think they give you a reciprocal function of either sine or cosine, and so I thought I would do one of tangent here. And so I want my vertical asymptotes, and that's kind of what defines the period for me. A normal period for cotangent would be or for tangent would be between the asymptotes from -pi over 2 to pi over 2. We want to start with the tangent function, really is what I like to look at. So y would be the tangent of x plus pi over 3. And normally we would find the asymptotes then of the tangent. And so for the asymptotes of the tangent, you take bx plus c equals plus or minus pi over 2. And so bx plus c here is x plus pi over 3. So we'd have an equation x plus pi over 3 equals pi over 2, and an equation x plus pi over 3 equals -pi over 2. And I know we struggle with the fractions sometimes. You just have to remember that you have to have a common denominator. So I'm going to subtract pi over 3. And maybe you remember me doing what I call the smiley face method, where we would multiply and multiply. Here it's kind of the eyes, and here's our mouth, and then our nose. Kind of a weird way to think about it, but it really works here. So we would have 3 pi minus 2 pi would be my products for going across there, and then the bottom would be 2 times 3, which is 6. So we get pi over 6 would be an asymptote for tangent, but it's a 0 for our cotangent function. So I want to keep that in mind. And then the other one, we're going to do the same thing. Here we're going to subtract pi over 3. We get x equals negative pi over 2 minus pi over 3. I'm going to do that little smiley face method again. This time I'm going to get negative 3 pi minus 2 pi over 6, which is negative 5 pi over 6. And so that's another 0 for my cotan. So when I go to graph this, let me get a graph. I'm going to bring it over here a little bit. And I know that I'm going to have asymptotes. I normally would have asymptotes for my tangent at pi over 2 and negative pi over 2. I'm going to stretch this out here a little bit. I'm going to go over here to pi, and I'm going to have one here at negative. Oh, I'm over a little bit far there. This would be pi and negative pi. So normally I would have asymptotes at negative pi over 2 and pi over 2. In this case, my tangent would have asymptotes at pi over 6 and negative 5 pi over 6. So I want to graph about where that is as far as my cotangent. So those are my zeros. So I have pi over 6. That's going to be a third of pi over 2. So I'm going to guess it's approximate here. I'm going to have a 0 about right there at pi over 6, and I'm also going to have a 0 at negative 5 pi over 6, which is almost negative pi. So those are some zeros. And then in between, right smack in between my zeros, I'm going to have a vertical asymptote. And to the right, I would have a vertical asymptote as well. What I would do to locate exactly where those asymptotes were is I know it's between my 2 zeros. So I'm just going to kind of find the average of those. I've got pi over 6 plus negative 5 pi over 6. And I'm going to divide that by 2. So I get negative 4 pi over 6 divided by 2. So that's times 1/2. And that is negative pi over 3 is where my asymptote is. So that's supposed to be at negative pi over 3. And I haven't changed the period other than shifting it left and right. So I still have a period of pi. So if I add pi to that, I would be at looks like I'd have another value, probably about right here would be a 0. So there'd be another asymptote in between here. And then my cotangent is the opposite of what I have. So in between my asymptote and a 0 on the left, I'm going to have a maximum of, or kind of a critical point, I guess, of 1. And then between my asymptote and 0, I'm going to have a point at negative 1 there. And so that's my cotangent function. Sometimes you have to get a little bit, use some tricks with those fractions though to figure out where our values are. But if we at least think about, okay, it's right in the middle, it's halfway between. If we divide by 2, we're going to have either an asymptote or 0, whatever we're looking for. Example 59, that is from lesson 4-6. And it's just using inverse sine and just figuring out what the function is. This is kind of an easy one because when I layer them on top of each other, anytime I take the sine inverse of sine or the sine of sine inverse, these two guys will just cancel each other out. So all I'm left with is what's in the parentheses, which is negative pi over 3. So again, kind of an easy one on that. You can also use your calculator for any of these to help you get your answer. Okay, the last example here is from lesson 4-7, and it has to do, lesson 4-7 had to do with the law of sines and cosines, and so I chose a problem that is not like the example associated with the review. The first, it says solve each triangle. So in solving the triangle, I want to find the measure of all the sides and all of the angles. And it says round side lengths to the nearest tenth and angle measures to the nearest degree. I'm going to start out with just drawing a triangle and filling in what I know. It does not have to be drawn to scale by any means. It just kind of gives me an idea of the relationship of the sides to the angles. So I'm going to call this angle A, angle B, and angle C. And then so side A would be opposite angle A. Side B would be opposite angle B, side C is opposite angle C, and then what those associated measures are. So A was 13, B is 12, and C is 8. So this is an example of giving you what I would call side, side, side. And to do side, 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 we're going to use the law of cosines. And there are actually 3 forms of the law of cosine, depending on what side and what angle you want. For this, I'm just going to start with A because I'll be able to find angle A. So my plan for this is to find angle A and angle B using the law of cosines. And then to find C, I'm just going to subtract from 180 to get that one. So I have a squared equals b squared plus c squared minus 2bc times the cosine of angle A. And I'm going to solve for angle A this way because I already have all the A, B, and C here. So A, it was 13. B is 12. And C is 8. And I'm going to simplify. So I have 169 equals 144 plus 64 minus 192 cosine A. Now it gets kind of sneaky here because I can add these together, but this is the coefficient on cosine of A, so I do not want to include that in my sum. This gives me 169 equals 208 minus 192 times the cosine of A. I'm going to subtract 208 from both sides, and that's going to give me negative 39 equals negative 192 cosine A, and then I can divide to get cosine of A by itself. And so I get cosine A equals negative 39 over 192, negative 192, which honestly the negatives would cancel each other out. And then to solve for A, I'm going to do the inverse cosine of both sides. Now make sure your calculator's in degrees when you do this, because to get A, I'm going to do the inverse cosine of 39 over 192. And I'm going to round my angle to the nearest degree, which leaves me with 78 degrees. So that's angle A. Now I'm going to do the same thing, and I'm going to do that for angle B. So for angle B, I'm going to start with B squared equals A squared plus C squared minus 2AC times the cosine of B, and I'm going to substitute values in for that. B was 12, so I have 12 squared equals A, which is 13, and C, which is 8. So we have to do a little simplifying here so that we can solve for B this time. So 144 equals 169 plus 64 minus 208 cosine B. Again, you have to be really careful. We can add these together, but the 208 again is the coefficient on cosine B. So I have 144 equals 233 minus 208 cosine B. I'm going to subtract 233. That's going to give me negative 89 equals negative 208 cosine B, and then we're going to divide by negative 209, which gives me cosine B equals negative 89 over negative 208, or 89 over 208. Then we want to take the inverse cosine of both sides. And I get B is going to be the inverse cosine of 89 over 208, which is approximately 65 degrees. I don't have to go through all of that with angle C, because I already know the other two angles. So the measure of angle C is simply going to be 180 minus the sum of the other two. So the measure of angle C is 37 degrees. And so now we've solved the triangle because I know all of the angles and all of the sides. All right, guys, thanks for playing, and come back with questions when I see